Welcome to this video, and in this video we are going to discuss about how to incorporate risks and uncertainties in our investment appraisal. So if I can take you briefly, in our previous video we discussed about incorporating inflation and taxation in the investment appraisal. So we looked at how do we incorporate inflation, where we look at the nominal rate and the real rate, and we said that if you have inflated your cash flows, or if the cash flows are inflated, then when you are discounting, you should discount using a nominal rate. And we looked at how to adjust a nominal rate from a real rate using the Fisher's formula. So we also looked at how do we incorporate taxation in our investment appraisal. And I said that as far as taxation is concerned, you only need to look at the tax you are going to pay, which is paid from your profit or from your income, and you need to know the timing of the payment of the tax. And another issue as far as tax is concerned is the tax allowable depreciation. So you need to know how to compute the tax allowable depreciation, which we compute from the depreciation, because depreciation is an allowable expense. So that was our discussion in my previous video. So as I said, in this video we are looking at risks and uncertainties in our investment appraisal. So when it comes to investment, as I said in my previous video, that there is always a period of sowing and a period of reaping, or a period of investment and a period when you expect a return on your investment. So because of that time lag that exists between sowing and reaping, anything can happen in that period and you don't know what can happen. So you cannot be optimistic 100% that if I am expecting a return of 1,000, that is going to be my return. You need to be pessimistic, and you need to look at what are the likely outcome in case, or what is the worst situation in case things don't turn around as you expected. So whenever you are carrying out an investment, you need to look at how are you going to incorporate the risks in your investment appraisal. That's what we are going to discuss in this video. So we are looking at the techniques that we use in incorporating risks in our investment appraisal. And when we are incorporating risk in our investment appraisal, you can use what we call the sensitivity analysis. You can use certainty equivalent factor, there is no S, certainty equivalent factor, or you can use probability, or you can use a simulation method. So we are going to discuss these techniques in this video. So what do we mean by risk and uncertainties? When it comes to risk, you have a known possible outcomes and you can be able to compute the probability of the outcome. Then that one is a risk. If you can be able to estimate a probability of the outcome, then the event is, we have a risk. But if you cannot, you have an outcome, but you cannot be able to compute the probability of that outcome to occur, then in that case it is uncertainty. So in uncertainties, we cannot be able to compute the outcome, but in risk, you can be able to estimate the probability of that outcome. So let's look at our first technique, which is the sensitivity analysis. In a sensitivity analysis, we are trying to assess the responsiveness of the NPV due to the changes in other variables. For example, we are looking at if one variable changes, how the NPV will be affected by the responsiveness of the changes in the NPV. So in our sensitivity analysis, we are looking at the variables that are used to calculate the NPV. If these variables that are used to calculate the NPV changes, what is going to be the effect of the changes of those variables on your NPV? For example, if you estimated an initial cost of 2 million. Suppose your initial cost increases by a certain percentage, or what percentage must your initial cost increase such that your NPV changes, or the NPV becomes 0. So we are looking at the sensitivity. We look at by how much a variable can change before the NPV becomes 0. So if you look at those variables that we have used to compute our NPV, for example, the income, the revenues, the variable cost, the initial investment, and other variables that we use to calculate our NPV, by what percentage should these variables change in order to make our NPV equal to 0? So when we are computing our NPV, or we are computing our sensitivity, we get the NPV, then divide by the present value of that variable. So let's look at this example. We have a project. Cost is this, and it has a life of 5 years. Annual sales, this means it's constant. The annual sales unit is this, and the selling price is this. So you are going to have an annuity of revenues. Then the variable cost is this, and the scrap value at the end of the year is 20,000. Then our cost of capital is 10%, or what called the discounting factor is 10%. Then we are supposed to compute the NPV, the sensitivity of this project. So when you are carrying out a sensitivity of the project, the first thing you need to look at is to get the net present value of the project. So once you get the net present value of the project, then you can be able to compute the sensitivity. Because when we are computing the sensitivity of the project, we are using we are looking at how the variable, or the percentage the variable must change in order to make our NPV a positive. So when we are computing so we have got the normal. This is our cost. This is our cost, and so this is the PV of this. This is our cost. This is our present value. You can get the present value of the cost. Then we have revenues from year 1 to year 5. Because we have constant, this one, it means you are having a constant revenues, which is going to be the number of units, which is 10,000. This is our number of units, times the selling price. Now, because we are having a constant, because we have the same revenues from year 1 to year 5, in this case, we are using annuity. This should be annuity factor of 10%. So if you get this times this, then times our annuity factor, we get our revenues as this. Now, the variable cost, we are also looking at the variable cost from year 1 to year 5. So meaning the variable cost is also constant, which is an annuity. So we are getting our variable cost, which is 20 per unit, times the number of unit, which is 10,000. Then you have the variable cost here. Then we are discounting it using an annuity factor of 10% of year 5, which is this. So this one is also an annuity. You get this cost. Now the scrap value are going to be get at the end. Remember, at the end of the year we have this residual value. This one. This is our residual value. So our residual value is 20. So this 20. So because it is a lump sum, we are not now using annuity. We are using a lump sum factor of 10% in year 5, which is this. Then you get the value here. Oh, sorry, I didn't put them. You get the value here. So then you add to get your net present value, as we saw in our previous video. Now, so this is our NPV. Our NPV is this. So we are looking at the percentage at which the variable must change in order to make our NP equal to 0. So if you are looking at the sensitivity of cost, if you look at the sensitivity of cost, so the sensitivity of cost, you are going to get the net present value, or the normal formula to get in the sensitivity, we get the net present value divided by the present value of the variable you are analyzing. For example, if you are looking at the sensitivity of cost, or the sensitivity of initial cost, we are getting our net present value, which is this, which we got from the other previous table, then divide by our initial cost, because the present value of the initial cost is this, then times 10%. So meaning that if our initial cost increases by 16%, automatically your NPV will be equal to 0. Or if the initial investment increases by 16.2%, then our NPV will become 0. You can try it in your calculations. Then we come to sensitivity, the sensitivity of the selling price. Remember, the formula is the same. This is our general formula for sensitivity. This one, the net present value divided by the present value of the variable. So the sensitivity of the selling price will be equal to the net present value, which you have already got, then divided by, this is our net present value, and this is our selling price. Remember from the other table. So you get the sensitivity of the selling price, which is going to be the net present value, which you got from the previous table, then divided by the present value of the sales price. So it means if your sales price reduces by 6.1%, automatically your NPV is going to be equal to 0. So for cost, we look at an increase. For revenues, we look at a decrease. You cannot say that if the revenue increases to this one cannot become 0. But for cost, if a cost increases, then it automatically affecting your net present value. For revenues, if the revenue decreases, then automatically they affect your net present value. So for cost, we look at the increase to affect the net present value, but for revenues, we look at the decrease. So you can now calculate the sensitivity of your sales volume or your net gross profit margin, which will be your sales volume minus the variable cost. You get your sales volume margin, or the margin, then divided by the present value. Or you can also look at the sensitivity of the scrap value. The sensitivity of the scrap value will be the net present value divided by the present value of the scrap. So please, you can look at that since you have got the general issue or the general knowledge about how to compute the sensitivity. Please, this is the key formula when you are computing your sensitivity. You look at the net present value divided by the present value of that variable that you want to carry out a sensitivity. Remember, we are saying if it is a cost, to change your net present value, it must increase. But if it is a revenue, to change the net present value to 0, the revenues must decrease. So that is the key issue as far as sensitivity is concerned. So another technique that we are talking about here is the certainty equivalent factor. So that is technique number 2 that we can use when we are, so this certainty equivalent factor. And as far as the certainty equivalent factor, the cash inflows are reduced with their certainty equivalent factor. So the first step that you do in a certainty equivalent factor is to adjust your cash flows with that certainty equivalent factor. Meaning you are going to get your cash flows minus times the certainty equivalent factor. So once you get then you get what called the certainty cash flows. The cash flows after adjusting for risk, meaning that certainty equivalent factor, it is the one that adjusts the risk from your cash flows. Now, once you finish adjusting the risk from the cash flows, then when you are discounting, you should discount your cash flows using a risk-free rate. I'm saying the first step, or step number one, when you are looking at, you adjust your cash flows by getting your cash flows. You get the cash flows, then times the certainty equivalent factor. Get your cash flows or the cash inflows, then times the certainty equivalent factor. In that case, you are adjusting the risk in the cash flows. So once you finish adjusting the risk in your cash flows, then you discount the cash flows using a risk-free rate. So a risk-free rate in normal cases is the rate on government securities. The rate on treasury bills or the rate on government bond is recognized as a risk-free rate. So let's look at this example. So let's look at this example. We have a project cost. This is the cost of our project, meaning this is our initial investment. So it is expected inflow. These are our cash inflows. This one, these are cash flows in these 3 years. And this is our cost of capital. That is okay. We can get that. So it is very important in this question to. So these are the certainty equivalent factor. In year 1, it means your cash flows should be reduced by 75% or 75%. Year 2, the cash flows will have this certainty equivalent factor, and year 3, the cash flow should have this certainty equivalent factor. Then the risk-free. Remember, I said once you have adjusted for certainty equivalent factor, then you must discount your cash flows using a risk-free rate. If you don't have a risk-free rate, but you have a return, you have a beta, you have a market return, then you can be able to adjust for a risk-free rate. So we shall look at that one when we are looking at cost of capital or when we are looking at portfolio in our other videos that we shall look at. So we are required to evaluate the project using the expected cash flow, then again using certainty equivalent factor. So these are our cash flows. So our normal cash flows, this is our initial investment, as we said. This is cash flow in year 1, cash flow in year 2, cash flow in year 3. So these are because our cost of capital is 15%. So if you are not adjusting, if you are not using certainty equivalent factor, then you adjust you discount using the normal cost of capital, which is 15%. So if we use the normal cost of capital, which is 16%, then you can get your discounted cash flows. Now, in the next step, we are adjusting for certainty equivalent factor. And when you are adjusting for certainty equivalent factor, because we have these factors, in period 0, we always have 100%. There is no risk in period 0 because that's where you are standing there. Period 1, they said we should adjust using 75%. Period 2, we should adjust using 50%. And period 3, we should adjust using 40%. So of course, if you adjust this one, this is going to remain the same. So we are getting this 75% times your normal cash flow, 50% times your cash flows, and 40% times your cash flows. In this case, we get these cash flows which have already been adjusted for risk. So certainty equivalent cash flows. So you are sure that you are going to get these cash flows 100% or at that level. of certainty. Now, once you finish adjusting for certainty equivalent, then when you are discounting, you are supposed to use a risk-free rate. So you are using a risk-free rate. So you can look at this at 6%. Period 0 it is this. Period 1 it is this. Period 2, period 3. Then you are getting your discounting factor, then times your certainty equivalent cash flows. So you are getting this times this one times this, and then you get your discounted cash flows. So that is how we adjust for risk using certainty equivalent factor. Remember what I said? You first adjust your cash flows with the certainty equivalent factor. Once you finish adjusting your cash flow with the certainty equivalent factor, then the cash flows are discounted using a risk-free rate. So another technique that we look at is the use of probability analysis. Probability analysis, you are adjusting using in this case, what you are calculating is the expected net present value. So to get the expected net present value, you are now using the probabilities. So what we do in this case is to get our cash flows, then times the probability of receiving that cash flows. So when you get the probability times your cash flows, or the times the discounted cash flows, then you get the expected present value. So you get the expected present value minus your initial investment, then you can be able to get your expected net present value. So let's look at this simple example on how to use this. So this is our cash flows. We have two projects, project 1 and then project 2. And each project requires this for investment. So both project of which cost is this. So now these are the probability for the cash flow to occur. For project 1, we have a project of 0.6 and your cash flows, these are present value cash flows, is 27. Project 2, this is the same project, sorry. This is we have another probability of 0.4 and you may get a loss of 4,000. So what we got to get the expected present value, or to get the expected present value here, we get our probability times the present value cash flows, then you get the expected present value. So you get this 0.4 times this, you get this. So you add this your total cash flows or total expected present value cash flows, then you get the total expected present value cash flow. So for project 2, these are the probability 0.5, 0.5, and these are the cash flows. These are the cash flows. So to get, as I said, to get the expected present value, you get the probability of your cash flows, then times the present value cash flow. So we are getting this times this, we get this, and this times this, we get this. So the total here, it's going to give us 14,000. So it means if you are getting the expected net present value, or the expected net present value, net present value will be equal to our expected present value, which is this, minus our initial investment, which they told us 12,000. So if you are to invest, it means this one has got a higher net present value and this one has got a low expected net present value. So this one is better than, or project 1 is better than project 2. So let's look at this other example. Still we are looking at incorporating risks, but this one is a bit different because it has 2 periods. Now we have an investment cost which is 350 and produce the net inflows. Year 1, this is the probability of your cash flows. It can be 0.3, can be 0.7. If the probability is 0.3, this is the cash flow. And if it is 0.7, this is the cash flow. And in year 2, if the cash flows were, the probability were 0.3, then here we have a 0.4 and a 0.6. And these are the cash flows. 0.4, 0.6, and these are the cash flows. Now, what are we required to do? So the company uses a discount rate. This is our cost of capital. Then what is the expected net present value? And what is the probability that the NPV will be negative? So in this question, or in this part, we have got two ways to handle this. You can use a decision tree, or if you are not very comfortable with the decision tree, then you can use what we call a payoff table. You can construct a payoff table and then do it using a payoff table. So you can look at those two, whichever is simple for you, then you can be able to handle this question. So let's look at the first step. In the first step, or in the first method, we are going to look at it. How do we do it using a decision tree? Then after that, we are going to look at how to use a payoff table. So the first step in this question that you are going to do is to get the present value cash flows, because we are just given cash flows, but they are not yet discounted. So your first step is to get the present value cash flows, meaning you are going to discount the other cash flows to get the present value cash flows. So what do we do in this? The first one is to discount this is our PV factor. Remember, our discount factor is 10%. So this is our PV factor in year 1, which is 10%. So we are getting our cash flow, which is 100, times our present value factor, which is 0.909, and we are going to get 91 our present value cash flow. Still in year 1, at probability of 0.7, our cash flow is 200. So we are getting 200 times our PV factor of 10% in year 1 is this. So we are getting this. So if you go to year 2, when the probability is 0.4, our cash flow is this. Then look at the present value factor of year 2, 10% is this. Then you get our cash flow is of 41. Still at 100, our PV factor is this. Then this is going to be our present value cash flow. When the probability is 0.7, we expect this at 0.4. Then times our PV factor, which is this. Then you get your present value cash flows. So it's the same with this times our 0.8, which is our PV factor. Then we get our present value cash flows. So once you get your present value cash flows in each year, I said we have two methods to do this. You can construct a payoff table, or you can use a decision tree. Whatever is simple for you, you can select. So let's look at the first, where we are using a decision tree. So if you remember, our main decision is that the probability can be 0.2 or the probability can be 0.7. These are the main decision. If the probability is 0 in year 1, if the probability is 0.3, we said we got a cash flow of 0.91. And if the probability is 0.7 in year 1, our cash flow is 182. Now, if we continue, so you go to B. If our cash flow is, if the probability is 0.3 in year 1, we have chances of having 0.2, 0.4 in year 2, and 0.6 in year 2. So the probability of cash flow being 0.4, the cash flow as we calculated will be 41. And if the probability is 0.6, our cash flow here will be 83. So when we are calculating for probability in this case, we move from right to left. So in this case, we are going to have 41 when we are calculating our expected present value cash flow. Will be 41 times 0.4 plus plus 83 times 0.6. So in this case, if you get this one, it gives you the cash flows at this point. Now, once the figure you are getting here, let's call it K. The figure you are getting here from this one, let's call it K. So to get the value here, or the present value when you are here, we are going to get what we have got here, which is what our K, then times 0.3 plus this cash flow, which is 91 times 0.3. So you are getting your total cash flows for this branch if it probability is 0.3. Now we look at the situation where the probability is 0.7. Still we are moving from right to left. So in this case, we are going to have, for this one, it is going to be, for the first one, it will be 165 times 0.4 plus 330 times 0.6. So you are getting now the value here, which is going to give us our value here, which we can call maybe J, the value we are getting here for these two. Now once you get the value here for these two, then you can get the value here. So which is going to be 182 times 0.7 plus our J we got here times 0.7. We got to this point here. So it means we have the value, the present value of year 2, and we have the present value of year 1. So when you get the present value of year 1, let's call it the present value of year 1. Let's call it which letter? We can call it M, which we got from this, and the present value of year 2, which we have got it from this one. Let's call it N. So meaning our expected present value will be, or our expected net present value will be equal to M plus N minus our initial investment. Then you can get your expected net present value. So that is how we work out, if using a decision tree, to get our expected net present value. So please watch for my next video and look at the other methods that can be used to determine expected net present value from this question.